The wavelength of a progressive wave. The wavelength of a progressive wave is the distance between any two adjacent wave fronts. Distance between two adjacent wave fronts. That's the wavelength. So we can write distance between two adjacent wave fronts. Distance between two adjacent wave fronts. That's what you do to get that single mark. The next part of the question says a cathode ray oscilloscope is used to analyze the sound wave. The screen of the CRO is shown. We are given the time-based setting and we are asked to find the frequency. How do we find the frequency? Right, we have to find the distance between two adjacent crests. The distance between two adjacent crests, that is from there to there, or any two adjacent crests. That distance there is 10 little boxes which are equal to 2 centimeters using the scale they've given us here. So this distance here is 2 centimeters. It's 2 centimeters. 2 centimeters. Right. According to the scale down here, we are told that 1 centimeter represents 2.5 milliseconds. So 2 centimeters is 5 milliseconds. That 5 milliseconds is our period. So period is 5 milliseconds. And from the period we can calculate the frequency. So frequency is 1 over period, which happens to be 1 over 5 milliseconds. This gives us a frequency of this question here. We should find the path difference between the waves meeting at C. So we need to find this distance. We need to find distance BC. We need to find what that distance is. And it's easy to calculate really because we have a right angle triangle. We'll employ Pythagoras theorem. We employ Pythagoras. So by Pythagoras, BC is supposed to be 20.8 squared minus 8 squared, which gives us 19.2. This is BC. Right. So the path of all the waves traveling from A to C will be the path of the waves from A to C will be this, and this gives us 8 plus 19.2, which is 27.2. Now the difference between 27.2 and 20.8 happens to be our answer. That's what they want us to do there. Right, that's our answer right there, 6.4. Right, that's how we show. Right, to explain item 2 there, we have to notice that these waves, when they meet at C, they have a path difference of 6.4 meters, which is 4 times the wavelength. Right, so since they meet at a whole number of wavelengths, they meet in phase. So to get your 1 mark, 1, we say here that the waves meet in phase. Waves meet in phase. Waves waves meet in phase, right? And 2, we say that there is constructive interference there, right? So that's what we do to get those 2 marks. Right, to answer item 3, we need to find the velocity of the wave. If we find the velocity of the wave, we know that there is a path difference of 6.4 meters. Then we'll just divide that distance with the velocity of the wave. But we know that the velocity of the wave is given by v equals f lambda, right? So the frequency, we found the frequency to be 200 Hz, and we multiply by the wavelength, which is 1.6. This will give us 320 meters per second. This will give us 320 meters per second. Right, so the 320, we'll then use it here. The time difference, delta t, equals, we now say, the distance, the path difference, 6.4 meters divided by 320 meters per second, and this will give us 0.02 seconds. 0.02. The next part of the question says the wavelength of the sound is gradually increased. Calculate the wavelength of the sound when an intensity maximum is next detected at C. Alright, so if the wavelength is being increased, the next time that we will have constructive interference at C is when we have this situation here, is when we have 3 lambda being equal to 6.4 meters. Alright, so that is the next time when we have constructive interference at C, which gives us, this gives us lambda as being equal to, it gives us lambda as being equal to 2.13 meters. 2.13 meters. That is how we solve this question. Alright, let us suppose the question had said the wavelength of the sound is gradually decreased. The next time when we would have a maximum at C, the next time when we would have constructive interference at C, it would be when we have 5 lambda being equal to 6.4 meters. And this would give us lambda equals and so that's what we would have done there if the question had said the wavelength of the sound is gradually decreased.